Okay, Algebra 1, this video is going to cover solving absolute value inequalities. So I'm using Desmos yet again for a visual, and we will be switching back and forth to pencil and paper to actually walk you through this procedure. So, right now, you are looking at an absolute value equation. 2 times the absolute value of x plus 5 minus 2 equals 2. Okay? And here are your solutions to that. Well, what if this were less than 2? Okay? Instead of equals 2. That means that we would only care about the solutions that are on this side of the graph, right? Less, where my x values are less than 2. And here we have where my x values are this is like the inside of the graph. And I'm going to show you what this looks like and what it would look like if we stretched it out so that this graph was not a V, but a straight line. Okay? Okay, so now let's visually, with pencil and paper, look at absolute value inequalities. Okay? Now recall that inequalities are a little different than equations. Okay, the way that they are different, one of the ways they are different is that you don't have a finite number of solutions. When x is less or greater than 5, for example, there are unlimited numbers, there are infinite many numbers that qualify to make that inequality true. That's why we draw lines on our inequality graphs. Okay? The other thing that makes inequalities different than equations is that inequalities, you have to flip the sign when you multiply or divide by a negative number. So why is that? I'm going to illustrate right here. It is because of the multiplication property of -1. Okay, so what do I mean by that? Well, what happens when I have a positive number and I multiply it by -1? Or a negative number of any size, okay? The point is I'm going to get the opposite of this number, or am I not? I'm going to end up with -1. -1 and 1, if you drew a number line, here's 0. -1 is at the complete opposite side of the number line. I've jumped the number line from here. I've jumped 0, and now I'm over here. So, what happens when I have a negative number? When I have -1 and I multiply -1 by -1, I end up with +1, don't I? So here I am at -1 and I multiply by a -1 or a negative number. Oops, I should have made that negative. I'm going to jump 0 and go on the other side of the number line. So what this means is that the larger that numbers get, the larger the magnitude of a negative number, the smaller that number is actually getting. And the larger the magnitude on this side, the larger the number is getting. But it doesn't work that way on the opposite side of the number line. So let's take a look at our parent function then of this graph. Let's pretend that this is the x-axis and this is the y-axis. Okay? Here's our x and y axis. If I want to know, and this is x equals 2, and x equals 1, and x equals 0, and here's negative 1, and here's negative 2. Okay? So if I'm solving x is less than 2, okay, I'm actually solving for this side of the number line, right? This is my solution, 2, and I want all my x's to be less than that. All right? That means that all of these solutions also have to be less than, magnitude-wise, less than this solution. Okay? I hope you're starting to see something, that this is forming a different kind of graph altogether that I will explain in a minute. But note, young people, on the negative side of the number line, as the magnitude of the numbers gets smaller, these numbers are actually getting larger. So the answer to this is that x is greater than 2. Negative 2. Sorry about that. Okay? So here, x is clearly less than 2. Here, x is clearly greater than 2. Okay? But these two go together. It's a compound inequality. It's absolute value, but it behaves like a compound inequality. And if you remember, young people, what this looks like, this is an and inequality. So less than or less than and equal to is an and inequality. Okay? So less than or equal to, and. Not Andy. Sorry about that. I just wanted to label that Y. Okay? So now let's look at our other option for inequalities. Okay? So here we have, let's draw our graph again. Okay, here's our y equals 2. Same thing. Okay, here's negative 2. Here's 2. All right. Here's our y-axis. And here's our x-axis. Okay. So if I want to solve x is greater than 2, I'm going to color this side of the graph, right? Because look, here's 2. Here's 1. Here's 0, negative 1, negative 2, okay? So all of my x's are going to be bigger than 2, right? So but if I want to do the same thing on this side, I need to color this part of the graph. But please recall, young people, that as the magnitude of negative numbers goes up, the actual value of the number is smaller. So this is actually x is less than negative 2. So you see how we have complete opposites here. The graphs look perfect, but this is x is greater than 2. This is x is less than negative 2. Okay? This is what we call an OR graph. This would look like this on a number line. Here's my number line. Here's my center. I've got one value here, and it's going to go off in this direction. I've got another value here. It's going to go off in this direction. I hope you can see the similarities between this absolute value graph and this number line that I'm drawing. Okay? So when we have greater than or greater than and equal to inequalities, we have an OR, compound inequality. Okay? So, when you go to solve these using algebra, I'm going to show you one example of this because it works the same for everything. All right? So here's our example straight out of Desmos. So we've got 2 times the absolute value of x plus 5 minus 2. Let's do greater than. Okay? Let's start with greater than. Is greater than 2. Okay? So just like with equations, I have to isolate the absolute value part. So I'm going to do that by adding 2. Okay? So now I've got 2 times the absolute value of x plus 5 is greater than 4. Do you see? Now I need to divide by 2 to isolate my absolute value part. So now I'm left with x plus 5. The absolute value of x plus 5 is greater than 2. Okay? So now I'm just going to do my thing. I'm just going to split this into 2 inequalities and pay close attention to how they go. Okay? I'm going to keep this the same for my positive solution. I'm just going to copy x plus 5 is greater than 2. Okay? Over here, I'm going to solve x plus 5, but this time I'm flipping the sign for the negative number. So it's x plus 5 is less than negative 2. Remember, I showed you why. Because as my numbers get bigger in the negative direction, they're actually getting smaller. So let's solve this. Subtract 5 from both sides. X is greater than negative 3. Okay? Here, let's take a look at this. Subtract 5 from both sides. X is less than negative 7. Okay? So when I would go to graph this on my number line, I would just draw my 2 lines. Here's my value, negative 3. All my x's are greater than that. And here I have negative 7. And all my x's are less than that value. Okay? The same is reversed if I was solving a less than. If I was solving a less than, I would have x plus 5 is less than 2. And I would also solve x plus 5 is greater than negative 2. Okay? One more time, this is why. Because when I'm solving an and, I'm solving between the 2 endpoints. X is less than 2, but as these numbers get smaller, quote unquote, as the magnitude gets smaller, they actually are getting larger. So I'm actually moving in the direction of increase here. Here I'm going in the direction of decrease. One more time, let's look at the OR. Okay, the greater than. When I'm solving something greater than, here my x's, my solutions are moving in the direction of increase. On the other side, though, on the negative side, as the magnitude of my numbers gets larger, My numbers are actually getting smaller. So I'm actually solving a less than equation. So I hope that makes some sense, young people. See what you can do with this, and I'll see you in the next video.